My name is Bert Bos. Welcome to this lecture. Good afternoon. I'm working for w3c, and this is one of a pair of talks. So if you want to know more about w3c, I'm not going to explain that today. There's another lecture on Thursday at the same time where I'll explain more about how w3c works. So I hope you know a little bit about w3c, the consortium that makes standards for the internet, for the web in particular. And I'll show you a bit of what we are working on right now, the new things that are being developed. I saw in the blog of this conference a reference to my name in one of the entries, and the writer of that entry asked himself the question if this talk about the new technologies could be considered hacking. And the writer apparently thought, yes, it could. And in a way, I agree with him. It's hacking, but it's hacking people's minds more than hacking technology. What we do in w3c is we try to create consensus among the technology providers, the people that create the hardware, that create the software, but also the users and the communities of users, trying to get them to agree on something that will benefit everybody and not just a few of them. But often it's hard work. It's sometimes political. It's sometimes finding compromises because we have some long-term goals. We want to improve the web, the way people can use web technology everywhere at any time. But to reach that goal, we often have to invent short-term solutions. We can't create something that will only work in 10 years from now. There are people that rely on it working now or next year. So short-term solutions, and in the back of our mind is still, how do we get via those solutions to a long-term goal? It requires creativity, and I think creativity is what's important also. If you talk about hacking, I think it's problem solving, it's being creative, but not only for yourself, but also creative, enabling other people to be creative in their turn. And w3c works in the public interest, trying to create the web for everybody, but also because it's a consortium, we have members who pay their membership dues. So it's also their interest. It's a balancing act. It's trying to marry those different interests together. So that's for the intro. The goal, the overall goal, you can say, is to have one web only. You want a single web, no matter what device you use. Whether you use it on a phone, on your PC, on a PDA, on a normal phone without a screen, anywhere, anytime, any device. You want people to be able to use the same information, the same web, and we want authors to be able to provide information for all of those with as little effort as possible. That includes access for people with different cultures, different types of education, different languages, of course. I'm talking in English now, because that's what I do best at talks like this. I can also talk in Dutch if you want. German, you can ask me questions in German. I will probably answer in English. But languages are important, and we want to enable all of those on the web. And that means that technologies, even if they are developed in one country, should be available in all countries. Other differences, of course, are handicaps. People with problems with vision, who are deaf, who can't move their hands correctly. All those kinds of handicaps requires access methods that may be different from the author who used different means to create information. And you have to remember, you have to keep in mind that we are all handicapped at some point in time. Maybe you're driving and you're using the web at the same time. You're using a GPS system, maybe. You can't use your hands at that time, or it's illegal to use your hands. So you're handicapped at one point as well. And of course, everybody's getting older. The population, at least in Europe, is getting older, and everybody is wearing glasses, etc. So you all get to know these handicaps at some point. So it's better to take care of those right from the start. And of course, people may have different preferences as well. You may not like yellow text on a red background. You may want to have that differently. That also should be possible. So I'm talking specifically about mobile access in this talk. It's just one of the examples, but it's one that's very important at the moment. And w3c just started something we call the Mobile Web Initiative, MWI, which is trying to set up guidelines and test suites and checking that content, applications, anywhere, everything is available on mobile phones especially. We cooperate with OMA, the people that created WAP. It's now called OMA, Open Mobile Alliance. We're cooperating with them on standards and guidelines. So one of a few diagrams I'm showing, this is an architecture for adaptation. Because even though we try to have the same content available everywhere, we know that it's not always possible. If you have a big map, 3,000 pixels wide, you won't be able to show that on your mobile phone. Not this year, probably not next year either, and maybe not even in 5 years from now, although that remains to be seen. But some adaptation is necessary. So this is the view, adaptation view from the author's side. Content on the left. Hopefully the content is the same for everybody, independent of the device, but maybe it needs some special parts in it that are only available for some users. And with the request for the information, the URL here, URI as we call it now, there comes something that we call the delivery context. Information about the user or about his device that is used in the adaptation process. I'll come back to that later. We have standards for those. And then after the adaptation, the adapted content is sent to the requester. So this is the author's side. Adaptation takes place in this view close to the server side. There's also adaptation that takes place on the author's side, closer to the device. The information comes in here, and inside the user agent, think of a browser or any other software that is reading the information and displaying it for the user. There are preferences, there are adaptation processes going on there also. For example, your own colors, your own screen size, your own fonts, any type of adaptation you might think of that can be done on the client side. So this delivery context that I mentioned, well, this is an example of what it looks like. There are two standards involved actually here. One is CCPP, which is the framework, the general syntax. It's an XML syntax, actually it's even an RDF syntax for those of you who know what RDF is. That gives you the syntax and the actual vocabulary, the keywords, the parameters there are called UAProf, User Agent Profile. CCPP is created by w3c, UAProf is created by OMA. And there's a little example, you probably can't read it in the back of the room, but, well, you don't really have to. Just an example of what you can find in such a device, in a delivery context. There's information about the color depths here, 12 pixels, the screen size, other things, etc. There's actually, let me go back one. It's actually used at the moment, all smartphones use this at the moment to send information about themselves to the server when they request information. Although in practice they don't send the same information at every request, they send a reference to the information, because sending a large file like this with every request is rather inefficient. So actually they send a URL that points to this information. And that's what the server then uses to adapt content to that particular smartphone. So that's something that's already in use. That's not really new. That exists for a while already. This is much newer. DI select, device independence select, is at the moment a working draft in w3c. It's quite stable. I don't expect it to change much anymore. But it's sort of a macro system, like if you program in C, you have the C preprocessor, CPP, or M4 is another macro processor. This is something similar, but it's only for XML. Inside the format you want to adapt, in this case a bit of XHTML, you put expressions, attributes, or elements that come from the DI select vocabulary. They are processed by a preprocessor, and they select which part of the document are actually sent to the client when it's requesting information. In this case, it's not really readable, but that's because it's the XML syntax. Normally you wouldn't do this by hand, but I'll show it to you here. I expect people here are not afraid of XML. This here says, this P here should only be given out when the requester has a width, a screen size of at least 200 pixels, greater than 200 pixels. And in all other cases, this P is left out. It's one of the possible syntaxes for the iSelect. The fact that it's an XML syntax gives you some limitations. You can only use it for XML. You can only select whole elements. You cannot include or exclude an attribute, for example, or part of an attribute. Only whole elements. But on the other hand, it allows you to use XML tools like a validator, a schema, XSLT processing. So it has benefits and disadvantages. Something similar, but for programs, is DCI, also working draft. I think it's about as stable as the DI select by now. May change a little bit still. It uses the same characteristics, the same parameters that you get from the device, but inside the program. It's an API, it's a library interface. So if you write a program that's executing on a client, on a phone, for example, and that program needs to know information about the device, such as the screen size or the battery level, whether it's connected to a network or not, those things it can ask via a standard interface. And where the iSelect is used for static content, its adaptation is done one time before the information is displayed on the device. DCI is used for dynamic content. It's for programs. So while you're executing a program on the device, the battery level may change, and then something may pop up saying that the battery is low, or you lost network connectivity, or if you resize the window, if you have a thing with a window on it, it may change the characteristics of what it displays dynamically. But it's using the same parameters about the device as the iSelect uses. So those two that I showed were done by a working group in w3c called the DI working group, the Device Independence Working Group. This is done by another working group, the CSS working group. You may have used CSS already for styling web pages. The media queries is another working draft in the CSS area. It's actually a candidate recommendation. So it's in the testing phase at the moment. It's stable, it's being tested. And that's similar to the DI select, but it's only for selecting style sheets. So it's much simpler. It's also usable either inside CSS or inside XML or HTML. The example that you see here at the top is HTML. You may know that at the top of HTML files you can link to style sheets with a link element, rel equals style sheet. And then you get the possibility to say, to give different style sheets for different media, for example, for a print style sheet, a screen style sheet, a handheld style sheet, etc. That already existed in HTML even before we wrote the media queries. And that's been extended, generalized. Now you can use parameters as well. So the third line here, for example, says this style sheet here is for a screen, for a PC, say, a typical desktop browser. But only if the width, the minimum width of the window is 200 pixels. And the fourth one is the opposite. It's also for the same kind of device, for a desktop browser, but only if the window is no wider than 199 pixels. You can extend that. There's more things you can ask if there's color, how many bits of color you have, if you need that, a few other things. There's exactly 11 parameters that you can ask for, such as the screen size, the width, the height, the device, how many pixels the total screen width is, aspect ratio, whether you have square pixels or not, things like that. And as I said, it's a generalization of what existed already in HTML and in XML. It's a bit simpler than the DI select, but it's more limited as well. So there's always a choice you have to make when you're on offer. What do you use for adaptation? This is one of the choices. So if you adapt something, you want to know what to adapt to. And hopefully you don't have to adapt to every single device individually. At the moment, that's actually what happens. There are content providers for mobile phones, and there are companies that provide adaptation solutions. You can buy software from them. And that software comes with huge databases of all the hundreds of different phones that are out there. And they provide rules, export systems, etc., to adapt your content to all of those different devices. That's costly. That costs a lot of money to do that. And also, it's very hard to keep those databases up to date because new phones are coming out by the month. So hopefully, we can reach a situation where there's more commonality, there's a sort of common base that all those devices adhere to, that they all implement, all support. And that's what we call the mobile profile. So mobile profile is a subset of all the technologies we have that we hope will be implemented by all mobile devices. We're creating them, w3c again, in cooperation with OMA, and we have them already for CSS, CSS mobile profile, XHTML, it's called XHTML Basic. Smile has one, SVG called it SVG Tiny. Those are profiles, they're subsets of the full specification. So for styling, for text documents, for multimedia, for vector graphics. We have them for others as well. So that's, if you stick to those, to what's in the profile, it should work everywhere, is the idea. We also have profiles for printers, we have profiles for TV as well. But I'm concentrating on mobile here. And we have something that combines all those profiles together. It's called Wicked. You have to pronounce it Wicked. And that's a working draft at the moment. I think it's more or less stable. They expect to be starting the testing phase early next year. And the 1.0 version of that, of Wicked Mobile, contains XHTML, SVG, SVG Tiny 1.2, CSS Mobile Profile 1.0, JPEG and PNG. And if you stick to that content expressed in those profiles, it should work on all smartphones. If it doesn't work already, it should work soon, or the new versions, is the idea. And it also will work on desktop computers, because those are more powerful. They actually support more than this. This is not specific to mobile, but I mentioned it here because the reason we're working on it at the moment is because of a request from the mobile content providers. This is a new idea for how to do layout, high-level layout with CSS. I don't know if the designers in the room, but they may have struggled with the famous 3-column liquid layout in CSS, how to use floats and absolute positioning, so all kinds of fancy layouts. It's quite hard. CSS is a bit, what we have so far in CSS is a bit too primitive for that. It is low level. You can position things, but then you lose the relation with other things that are also positioned. So this is an old idea. The idea is also already 10 years old, but 10 years ago there was no interest in it. The web wasn't ready for it. But now the mobile providers especially want to build portal sites. That's the standard use case. Sites that are built up of smaller sites coming in from various other content providers. Think of a news portal, for example, where news is coming in from the various news providers, a bit from Reuters, a bit from France Press, etc. And they all have their window, and the content is delivered. It has its style already. It just has to be laid out on the screen. And it has to be laid out differently depending on the screen size. If you have a big screen, you can put many things next to each other. If you have a small screen, you can only create one column. If you have a high screen, you can put things underneath each other, etc. So how to do that with CSS at the moment, it's quite hard. You can do it, but if you have a different screen size, you have to do a lot of work to create a new layout for that screen size again. So this is an idea to describe the whole layout basically in one line. I put it on 2 lines here for readability. You can see this as sort of ASCII graphics. This says I have a table-like layout, a grid, we call it, with two rows. The top row is a single large cell called A. Every cell has a letter for its name. And the bottom row has 3 columns, B, C, and D. And then you can position other elements in the document by means of the position property. So something called main goes into the top part, the weather goes in the bottom left, news goes in the middle, and commercials or whatever goes into the top, the bottom right slot in the grid. It's a simple example. There are other ways, other extensions to set the size to specific sizes, or make the size flexible or not. This is the basic principle. So this is a draft at the moment. As I said, the reason the CSS working group is working on this was a request from the mobile vendors, mobile providers. The portal, I mentioned that. So it is the first draft was just published a week ago, I think. So it's very early. What I show you here is the current idea, but it may still completely change depending on what feedback we get. So if you're interested in this, please give us feedback. You find all the information on the w3c site, w3.org. So the advantages of this idea, the grid layout, whatever syntax we finally end up with, is that it's similar to tables, and people know how to do layout with tables. Even though we tell them don't use tables for layout, because it's bad for accessibility and bad for reusability of the content, they know how tables work. So this is a way to use the good parts of tables, the implicit alignment, the things everything in the same row has the same size, everything in the same column has the same size. That's implicit. You don't have to juggle with percentages of pixels. So that's very nice advantage of table, and that's provided now by the CSS layout. And the other thing that is not available with tables, but that was available with positioning in CSS is you can change the order of things. So if you have your portal site and in the source HTML file, it starts with a menu, a navigation menu, then you get a banner, then you get main content, then you get a copyright, and you get some other things. That order may be correct for some device, but it may not be right for another one. If you have a big screen, you can put for example, the menu on the left, news items in the middle, commercials on the right, copyright at the bottom. And that order, left to right, top to bottom, may be the order that it has in the source file. But if your screen is smaller on a phone, for example, you may want to show the main content first, even though in the source file it's not the first thing. And this allows you to do that. So because it uses the position property from CSS, you can put things in the top left corner, even though they are not the first thing in the file. So that's important for keeping the independence between the source and the visual at the end. And it's recursive. That means you can nest these layouts. So if you have a top-level layout, and in the various slots, there may be individual layouts again. So if you get content from various authors, and each author has made its own mini page, its small page, with its own layout, you can just embed those in the bigger layout. You can do that with tables, of course, as well. So that's it's a nice feature of this idea. Multimodal, of course, is very important if you have small devices, because you don't have a big keyboard and you don't have a mouse. You have to interact with the device in some other ways. Or imagine you're in a car and you're interacting with the computer via the board computer. It has some knobs, some handles. You can use your voice to talk to it. It will speak to you in response, because sometimes you can't use the screen. So how to use various ways of input and output together is the subject of another working group in w3c, the multimodal interaction working group. And one of the big challenges there is how to switch the modality, the way of interacting while you're interacting. So imagine a situation, for example, you want to go somewhere. You have used your mobile phone to set up a route to somewhere. You have your GPS system. You said, I want to go there. It has calculated where you should go. Then you get into your car. You put your phone into the cradle. You can't use the phone anymore because you have to use the steering wheel. But the board computer takes over. You interact with it now via the knobs and handles and the voice that it has. The same session, the same information, but on a different device. Being able to switch that is quite hard. Because you can't imagine, you can't assume a certain kind of interaction. You have to abstract it away. There's no keyboard, for example. There's no mouse. Sorry, different kind of mouse. Don't know if you can read that. This is basically the architecture that the multimodal working group came up with. Input at the top, speech, handwriting, keyboard, mouse, other things. Some input is automatically generated by your device. Information about the environment you're in, the temperature, the lighting level, sound level, if there's a lot of noise around you. Those things may be automatically generated and given as input to some application. At the bottom there's the output via audio, voice, synthesized voice, graphics, text, output to a printer, etc. The input has to be interpreted. Usually some sort of grammar is employed for that. The grammar describes what kind of input is expected at some point. That's a lexical level, syntactic level, has to be interpreted. What does it actually mean? And in that process, there's something, a technology that I'll show in the next slide called Emma that plays a role in there. The various input modalities are integrated. You can say something, and at the same time you can point to something. You can say, for example, I want to go there. And while you say the word there, you point with your finger or with a stylus or something on a map. And the system has to integrate those two kinds of information. The voice that says there, and the screen that's being pointed at. And those two things together is information, for example, where you want to go to, or where you are, or things like that. So after the integration, that information is processed by some sort of application, whatever service you're interacting with. Keeps track of your session. As I said, you may want to switch from a PC to a phone to an onboard computer to something else while you're interacting with it. Information about the various parts of the system. Adaptation that I already mentioned here at the bottom. We can use DI select, media queries, the DCI that I showed, and other things if you need to. Styling, I also showed you that in the previous diagram, and you get to the output. Oh, before I go to Emma, I'll show you some other thing first. I think I have time, yeah. IncML, if the input is in the form of handwriting, with a stylus, for example, or with some touch-sensitive device, or even a force, pressure-sensitive device. If you have a Palm, for example, Palm Pilot uses that. Many phones use it now as well. The Sony Ericsson phone, for example, have that. This is a standard format that we're trying to get implemented by everybody. So the various devices use the same format for encoding those handwriting information, the traces you make with a pen. It's called IncML. It's a little example. It's a complete file here, but there's room for much more information. This just has coordinates. Every pair of numbers is a coordinate. In the background, you can see what it looks like, this little spiral here. But there's actually room for much more. You can have pressure information in there. You can if you have different pens, you can identify which pen this was written with. There's various kinds of compression schemes. If you this is just coordinates. You can also encode things by deltas. So go up by so many, go left by so many. Sometimes that's easier. There's various ways of encoding information inside IncML. So Emma, this slide is again too full. You probably can't read it. But maybe you can read just the keywords here. So Emma is a system for annotation. Is that a question?
Yeah, good question. With IncML, can you...
I'll repeat the question.
All right.
Okay.
Oh my God. Okay, I think it works now. Can you record the time between the points in a signature? Because in handwriting analysis, one of the things that you don't get just by looking at the product is the speed with which it was written. So if I could encode the speed with which your R is written, it's very helpful to me to know if this was a forged signature. Does IncML provide the time capabilities as well as just the position and the pressure?
Yes, it does, yeah. This is really a very simple example because there's no more room on the slide. But yes, you can record all those information. Okay, Emma is a system for annotating partial interpretations. This example here is, you can imagine a speech input system. For example, you are reserving a flight over the phone. You're interacting with an automated system and it asks you at some point, where are you flying from and where are you flying to? And it expects you to say 2 names of cities. And in this stage of the processing, imagine a system composed of various parts, each doing its work, and then passing on partial information to the next part of the system. At this stage in the processing, the system has thought it heard 2 words, Boston and Denver, but it might also have been Austin and Denver. So what you see here in the middle is a little XML format that it uses between the systems, between the 2 parts of the system, to pass on the information. But this is embedded inside Emma. So in the Emma information that's wrapped around it, this says actually we have two interpretations here. The idea is that you pick one of those, and one of the interpretations has a confidence of 0.75, the other 0.68. So 75% chance that this is the correct interpretation, and this one a little lower, 68%. It may still be that the first one is not right and actually the second one was right. The next stage of the processing may use other means to determine which one of those was right. For example, it may ask again, or it may compare to something you said earlier, or anything. But at this stage, the information has been encoded as, so far we know two interpretations, and we have annotated them with the confidence level so far. There's also a timestamp, and there may be other things as well. You may point to proof, to extra information that why the system thinks this is the interpretation, may point to grammars that it used, to vocabularies, and various annotations you can put in there. So this is meant as a standard way of annotating information in the interpretation phase between various parts of the system, because the system may also be distributed. There may be some part running on the device close to the user, some part may be running on a proxy, some part may be on the server that does the final processing. And communicating between those could be done with Emma. Okay, what's Emma? Okay, yeah. Oh, yeah. I think I'm going to make it in time. This is something that's commonly referred to as binary XML, although if you say binary XML, there's a political side to that. People don't like to speak about binary XML because one of the main characteristics of XML is that it's text. So when you say binary XML, it looks as if you're taking away one of the big advantages of XML. So this is actually called efficient XML interchange. It's not XML as such. It uses the model of XML. That means the tree structure of XML, where every node in the tree is called an element. It has children, and it may at the leaves it may have text content, and every node, every element may have attributes. That general model that we call the XML info set is going to be encoded in a different format, not as text but as a binary system, and that's called EXI, efficient XML interchange. It's not as simple as compressing the XML. If it were that simple, then we would have done it long ago. Well, actually, you can do that already. Many servers will compress the XML automatically. If your browser tells your server that it accepts compressed content, then you will get it compressed. That's not the point. The point here is it's for different types of applications. For example, for streaming. XML has this tree structure. You can start processing already, but you may sometimes have to know the end of the element before you can process the start of it. And also there's a rule in XML, if there's an error, you have to stop at the error, you can't process anything more. Now this is going to be used for streaming, for video streaming, for example, and if there's an error in the stream somewhere, you don't want to stop. So the rules are slightly different here. Also, this is for devices that have limited memory. So compressing would have helped during the transport, but it wouldn't have helped during the processing, because you have to uncompress information first before you can find the information in it. So if the encoding is such that you don't have to decompress the parts that you don't need, you can use it much quicker. So think of this as a system where the information is chunked in some way. You can skip directly to the element you want to process. You can skip everything in between. You don't have to decompress. I'm talking about it as if it already exists. That is not the case. All we have at the moment are the requirements. So I'm mentioning some of the requirements here. We don't have this actual format yet. The working group just started last week. So we'll see what comes out of it. There are some proprietary systems out there. People sell various binary streams that are able to encode XML. None of them completely fits the requirements, so something has to change somewhere, and hopefully we will get a common format out of that in the course of next year. I think this is the last but one slide. Yeah. There's one more technology to come, but I'll stop for a moment and talk about good practice. So I showed you the models, the adaptation view. Adaptation is done close to the source or close to the client. The multimodal view with the various steps of interpretation, which doesn't say whether it's done at the client or at the server. It can be done either, or it can be done in between on a proxy. But there are some considerations to keep in mind when you set up a system that adapts content to clients, to devices, or to users. One is that distributing the processing is a good thing. No bottlenecks. If all the requests have to be handled on the server and the server has to do all the adaptation for each client, that's a lot of work. That means that when there are lots of clients at the same time, the system will slow down. It's much better to keep the server simple, just send out the content as quickly as you can and distribute the adaptation to proxies or to the client itself. That's what's done with style sheets at the moment, for example. You send the HTML and a link to a style sheet, and the browser gets the style sheet and adapts the content to the current screen. The browser is doing adaptation in that respect. So that's more efficient. It's not always possible. Sometimes adaptation requires, the typical example there is when the client is not allowed to get a certain content. For example, it's content you paid for. You can't send everything to the client, and the client himself has to check whether he paid for it or not, and then displays only those things that he paid for. Well, that's maybe a utopia, but in practice, people are not going to try that. Other thing is protecting children, for example. If you have a filter somewhere, you want to protect your children from whatever, violence or pornography or something else. You want the content to be filtered before it gets onto your computer, because at sometime the children still have to be protected, but are they already old enough to hack your computer, and they may get at the content before it's filtered. So you want that filtering to be done earlier. So there are limits there. But as I said, closer to the client is not only is more efficient, but it also allows more users. Applications that the author may not have thought of. The author may have thought he prepared for all the possible clients, all the possible ways you could use your information, but you as a user may think of something else. I sometimes give the example what I'm doing myself. I collect information from some sites with a Perl script. I'm not using a browser. I'm using a little Perl script that collects information from various sites, collects them, creates a single file from those, and that's what I see. None of those sites know about each other, but I have a little script on my site. It's not a browser, it's just a script that uses that information. So the adaptation is done completely by me. It doesn't use any of the visuals, any of the images, any of the style sheet. It just uses the raw text. So enabling that, innovation is driven by that, I think, in many cases. So that also is important. And there is a concern, privacy also. You don't want to tell everything about yourself to the server. What device you have, whether you're colorblind, whether you're handicapped, all those things. Some services you may want to give that information because then you get better information back and you trust them not to do wrong things with that information. In other cases, you want to keep that to yourself. And ask the service to give you everything it has and do the adaptation yourself. When I tell it like this, it seems pretty straightforward, black or white, don't give the information away. In practice, it's actually more complex than that. One example, if you use a style sheet to style the information, you can provide various style sheets, and in the style sheet you can provide various background images, for example. Now it's the client chooses the best style sheet and the best background image, but it may be that the background image is not actually visible. It's a transparent background image. It's only there to let the server know that you picked that style sheet. So there's still ways for the server to know what adaptation was taking place at the client, because you loaded a certain style sheet, because you loaded a certain image. There are ways around that. You can hide behind randomly accessing information, for example. So it's more complex than just client side is good, server side is bad. That's not the case. Okay. So the last one. This also is really just started, just like the efficient XML interchange that I told you about. This started, I think officially it started last week. The working group hasn't even met yet. But this is something you can see on our website appearing soon, I think. Most of what we've done in w3c so far is documents, static information, because that's the most flexible kind of information. It's what you can do the most with. But you see more and more people using applications, JavaScript, not just to enhance the page a bit, to provide a drop-down menu, but something that you can really call an application, mobile code, it used to be called. You download it, it runs without installation. Java is for that, of course, but Java is a programming language that's not for everybody. So many people like to do that in something like JavaScript. Well, the Google Maps is an example of that. No, the Google Mail, sorry. There were others like that. So we just started in w3c a working group called the Rich Web Client Working Group, RWC, which is going to collect information, the technology that exists, and probably going to write some new APIs. It will also have to work, of course, on security, device independence, because current JavaScript programs are not really device independent. They work on one screen, but not on the next one, and not on a smaller one, and they don't work without a screen either, which is bad for accessibility. People that are blind, for example, won't be able to use much of that. Internationalization also an important aspect. If you write an application, it has to be used in many different countries, in many different languages. How do you deal with that? When people write traditional programs, there are systems for that, or libraries that help you with that. Those don't exist yet on the web. So eventually we hope to have an application platform on the web with all the benefits that, well, most of the benefits that documents have so far, that they are device independent, reusable, accessible, etc. Yes. Microphone.
Yeah, for me it sounds like I think about the term Ajax when I read this one.
Right. Yes.
And does the w3c include this term, or just inventing a new one?
No,
because
no,
Ajax is not official. It's just, I don't know where it come from, but it's in use.
Yeah, right. Yeah, indeed. Used to be called DHTML. Now everybody talks about Ajax, and the main part in Ajax is an interface in JavaScript called the XML HTTP request, if I remember correctly, which is rather underspecified and doesn't work interoperably everywhere. So one of the goals of this activity, indeed, is to standardize that, hopefully backward compatible, if possible, indeed. That has to be remains to be seen if it works on all devices, but that's the goal, yes, to take that interface, generalize it, and have it implemented everywhere. But only one of the goals. There's more goals than that. But yeah, Ajax is a part of this, yes. Okay, I think I'm at the end. Yes, if you want to read this online, this is the URL. I guess I have to give this to somebody, then it gets into the proceedings or something. But this is where you can find it. I think I have I don't know if I have time for questions. If not, you can also find me. I'll be here the whole week.
5 minutes for questions.
5 minutes, okay. I think there's a break after this, so you have actually lots of time for questions.
I got a question about media queries. And what is the browser expected to do when the resolution changes, for example, when the window is lowered or something like this, or it's made smaller?
Yeah, that's a good question. We didn't specify that originally, and the first implementation in the Opera browser was not dynamic. It evaluated the query when it loaded the style sheet and not afterwards. I think in the latest version they fixed that. Now it's dynamic, and that's what we want to have. So somehow we'll issue an errata or something to say that we intend this to be dynamic. Some time ago there was a prototype implementation in Amaya, the editor browser of W3c, done by some people in Australia, and implemented an earlier syntax, an earlier idea of this, and they were completely dynamic. You changed the window size, or you increased the font size, and the whole layout could change from 3-column layout to 1 column or other way around. It should be completely dynamic eventually, yes. More questions?
Does XC take into account existing and in use binary formats like the EBML used by the Matroska video format?
Yes, before we started the working group, we had another group that wrote the requirements, and one of the things they did was compare all the existing solutions. There was something called efficient XML, I believe. There is the OMA has a binary format that they use on some phones. And there are more. I think there's 8 or 9 or so, or something like that. They all compared those, and all of them are input to this working group. I don't think any of those will be taken as is. None of them is really complete with respect to the requirements, but yes, the people that created those formats are also in the working group, and hopefully they come to a common format together.
How many people are working for the W3C organization?
How many people are working for W3C? Yes, there's another talk on Thursday, but okay, W3C, there's the team, the people that actually work for W3C, of which I am one, which is about 60 people. And there's the consortium, which is the members. There's about 400 members, companies, organizations, universities, etc. That's about 400. And so most of the working groups consist of one person from the W3C team and 10 or whatever people from the members. And of course, there's also the public input. We have public mailing lists where everybody can join. All the working groups have public aspects as well, even though the working group proceedings are often member-only, but every working group has a public mailing list as well. But I'll talk more about that on Thursday. That's it? Okay, thank you for your attention.